Hey everybody. So let's continue doing the self mock interview practice using the blind 75 essential questions. And today, so I'm in the section of LA, and I will start with find minimum in row data sorted LA. And in the interview, it can be assumed that interviewer is gonna ask a follow-up question, which is the next one called search in rotated sorted array. So I'm gonna start with the first one, and then as a follow-up, I'm gonna tackle the second questions in the rotated sorted array program. So let's do it. Okay. So the question starts with we have inputs of array of integers called nums, which is ascending order. But the problem is that it is rotated. Okay. So what's the goal? Okay. Let's do the goal setting first. So we want to return an integer. Return int, which is output is one, which is the starting index, starting number actually, not the index of the rotated array. Okay. So if there are 3, 4, 5, 1, so this array is used to be 1, 2, 3, 4, 5. So we need to find one. Uh, and then in this question 2, we need to find 0 because 0 is the starting point. If it's not rotated, then we can just simply return 11. So what's the constraint? Constraint 1. Okay, so what's the constraint? Do we have empty input? Maybe possible. Possibly empty input, which requires edge case. And do you have any duplicates? Okay, there's no duplicate. Um, as question says, no duplicate. So n is sorted and rotated between 1 and n times. Good. And the question says there are negative numbers. But I'm pretty sure we don't have to care about in this situation because there's no multiplication or plus or negative. Okay, so the question is saying you must write an algorithm that runs in all of log n. Um, so what does this mean? Okay, so that's the constraint 3. Um, Runtime must be all of log n, which is the best we can do. Uh, so why do we have this? So the question, so it is because if we use loop for each num, then find min takes all n, which is super simple. So I can do one example. So just simply return min of nums. This is all n, and it still passes the programs. So if we simply use this min as a function, like everybody can solve it without any efforts. Um, so that's why the question defines that we need to use log n as a solution. So we cannot use ob n. We need to optimize this solution. Um, so what's the idea? So we want to optimize, and log n we can easily think of binary binary search as a solution. So binary search, uh, I'm sure everybody knows already, but I'm gonna implement anyway. So use binary search and find the smallest, not the smallest. Actually find the starting number, and this is of log n, which satisfied the requirement. So I'm gonna implement this. But first we need to do the edge case first. Edge case, if if not nums, return none. Oh, actually nums are defined to be lengths larger than 1, greater or equal to 1. So we don't have to do this edge case. Okay. Okay. As an edge case, maybe we can first do if length of nums equals to 1, then return nums of 0. That's the edge case. So now we do binary case, binary search. So I'm gonna do low and high equals 0, and nums of length of nums minus 1, and then while low is less than high, um, and then at the end we want to return low. So binary search always start with declaring a variable low and high, and using the while loop um, to compare low is less than high. So what are we going to do is create a mid, which is the average between low and high. And in Python, we want the integer from the division, so we use the double slash. Um, this way we can get integer as a floor function. So let's do one example. So in this case, so example, so low is 0, low is 0, high is 2, and what's the mid? Mid is 7 in this case. So mid is 7. Um, since mid mid is higher than 2, we let high. So we in this case we need to increment low. Low is mid, actually plus 1, because we already know mid is higher than high. Um, and then else we let right equals mid, which is the opposite. So let's do that. So if nums of mid is bigger than nums of high, um, and then we increment the low, else else uh, high equal mid. Okay, let's do example 2. Oops. So this question returns 4 as a low. Okay. So actually we need to. So the question says we need to return actual number, not the integer. Um, so this is not this is not actual number, so we need to return nums of log and then do the test. Okay. Um, what are the other options? What about 0, 1, 2, 3? Okay. So we're going to submit. Okay. Um, it's not two first, but as question says, this is of log n, um, which is good. So I think I'm gonna continue as a follow-up. So interviewer is gonna ask. So now that we have these functions to find um, minimum number in the related sorted array, we want to do what we want to do next is using this function. Uh, can we find search in rotated sorted array? So the question says, if you have this input 4, 5, 6, 7, and then 0, 1, 2, again, it is assembly sorted, but it's rotated. Um, and then we have target. So we want to do this search of this target, and then we return integer. So the difference from previous question and this question is that previous question we were returning index, but in this example, in this case, we need to return index that nums of index equals to target. So we want to somehow utilize the previous questions to do the search. But what is the problem of using binary in this example? So how about using binary search? So if we the problem of binary search is that binary search requires input arrays to be sorted. It doesn't matter if it's ascending or descending, but it has to be sorted and and not rotated. So that's why we cannot directly use binary search in this case. But we want O of log n as an solution. So constraints one, we want solution. Uh, but let's continue with the constraints first. Constraints two, maybe three. So do we have input empty input? No, we don't have empty input. So no empty input. Okay. What about duplicates? So so all elements are unique. Good. Which means we don't have to care about um, ignore ignore duplicates. So what else? We have negative, but it doesn't really impact in this case. So I think we have good constraints and goal setting. So we want to return the index. Okay. So what's the idea? We want so to do log n solution, we still need to use binary search, and partially this input is sorted. Um, so my idea is to first use the previous question, find starting index from previous question. So that's to do one. So my idea is to first find starting index, and then to do two, run binary um, for for either for either starting start index uh, between start index uh, between the right index or or start index is in the middle, and then use the left index. Actually, just zero index. So that's the goal. Actually, we can just replace by n as a length. So n is length of nums minus one, which is the end of n is end of array. Okay. Uh, so we want to have. So let's use previous question uh, to implement to do one. Okay. So I'm gonna create a def. I'm gonna create a def of find start index, and which returns actually index of integer. Um, but previous question was returning actual number, so we modify to return index, and then as an input, we gonna take just nums, right? Okay, so we're gonna take input of nums. So that's the function. So to do one, okay, to do one, we need to find start start index equal find start index, and then give nums as input. Okay, and then we need to run binary search, right? So to do two, we need to create binary search. Binary search. So def of binary search, and what do we want to return? We want to return index. So return index, and then we need to return uh, low and high. Low is integer and high as integer. Um, so we already have low and high, and so while low is less than high, if if nums of mid equals to target, we already have target. So we just, if it's equals to target, then return mid. Else if else if, so for example, if it's 4, 5, 6, 7, if it's 4, 5, 6, 7, and target equals 4, so we want to do low is at 4 and high is at 7. So we want no, actually target is 5. Sorry, target is 6, and then mid becomes 5. So since mid is less than target, we need to increment low equals mid plus 1, right? So elif nums of mid is less than target, we need to increment low equals mid plus 1, and else uh, we need to decrease high equals to mid. Okay, and then at the end, if if the loop finish, we need to return that doesn't exist, meaning -1. Okay, so let's do one example. Uh, so we want to return binary search of nums. What's the starting index is 0, and in this case starting index, so ending in index for 4 5 6 7 is 1 0 1 2 3. So we're gonna define 3, and then we need to change the target. Let's see, so let's say target is 6, so the binary search should return, yeah, 2 as an index. What about if this is 3? It should return -1. Great. So that's the binary search. Okay, so to do 2 is done. Now, as to do 3, yeah. So to do 3, to do 2 was creating uh, default binary search, which is done. So now we're gonna run binary for either starting index to n or n0 to starting index. So we need to decide. So after getting start index, so if nums of starting index, if target is bigger than and less than nums of starting index, then we return binary search starting from 0 to the index starting index. Um, to the starting index -1, because starting index is 0, but we want 7 in the array. Okay, so else we just starting index is the start, and then ending value is the not n, as we defined here. So let's do the test. Let's do the test. So example 1. Oops. Target. Sorry for the typo. Okay. What about 6? What about 4 actually? Yeah, so this should be equal. Okay, can we submit? Let's see example 3. Target is 0, but input we have only 1. Okay, let's submit. 1 1. Okay, so 1 1 seems not working. Yeah, so here again we need the edge case. Um, so length of nums, if n is 1, we don't have to do the computation. We just need to return nums of 0. If it's if the length is 1 and nums of 0 equals target, then return nums of then return 0. If n is 0 and nums of 0 is different from the target, then return -1. So length of 1 is actually a little tricky. Okay, okay, so we should use length of nums. Okay, what about 1, 2, and find 2? Okay, okay, so what's going on? So in this case, 1, 2, 1, 2. If the target is 2, the binary search is not working. This is an interesting question. Um, so in my head, I can do the debug. Um, so if we have 1 and 2, low and high, mid is mid is 1 because it's taking the floor of 2, and then mid is not same as target. So we need to check these conditions. So first, mid is 1, and then target is 2, which is less than 2. So my low is gonna become mid plus 1, which means 2 is gonna be 2. But then end of loop, uh, low and high is gonna be equal. So we need to exit this while loop before we check if nums of mid is equal to target. Uh, that's why it's returning -1. This is very good practice. So at the end we need to uh, check if not the mid, if low, because we end up low, it's gonna be equal to high. So we do the check if nums of low is equal to target, then return low target. It's not working. Okay, so right now, okay, so I'm getting close to the answer. So what's going on is this index -1. When the length is 2, starting index is 0, but then starting index -1 is -1. And then if we define -1 to the input of high, then this, so everything is not working. So okay, so what we need to do is to change the order of if else. So this has to be if, and this has to be else. Uh, so this is a very good question to see order of if else doesn't matter actually. So if nums of starting index is less than target, and also it's less than nums of n, we know n is always the end of index. Uh, so that's why this starting with this if statement makes sense. Great. Now we have accepted answer. Okay. What about other? What about other cases? 2 and 0. Nice. How about 4? Great. So let's submit. Okay. Finally. Okay. It's working. Good chunk of runtime. Okay. So I think this question was really good to catch up using binary, and also as a follow-up, rotated sorted array. I made lots of try and error, but I learned a lot. Um, so some of the good practice is to always we need to think about which if statement comes first, and whether binary search should return index or actual number, and some edge cases for length is 1. Yeah, so that's everything.